Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a portion of distributed forces. So you must first master derivation of formulas for volumes, areas and arcs or lines, and also familiar with them. And this part will be to enhance your thinking skills, especially in locating centroids of volumes, areas, and arc lines, which are necessary later in analyzing a system with distributed forces. Level 16, locate the centroid of the plane area shown. So here is the given figure. So we have radius here, this is the center, so we have a sector, and we have the remaining two identical triangles. So let's solve this. From here to this corner here is R. So barred x is 0, bar x sub g is 0, or barred x is 0 because of symmetry. So the centroid will definitely lie here, somewhere here. So this is R, and R is square root of 60 square plus 60 square. So R is square root of 60 square plus 60 square. It is equal to 60 square root of 2 mm. That's also R. Then this is the centroid of this sector. Let's call that H, and take note that H is 2R sine theta over 3 theta in general, if you can remember, where theta is half of this entire bisected angle, since the horizontal and vertical legs of this triangle are equal. So this theta here is 45 degrees, or pi over 4. So theta is 45 degrees, or pi over 4 radians. Substitute. H is 2 times 60 square root of 2 sine of 45 degrees over 3 times pi over 4 radians. So solving for H is 50.93 mm. Therefore, y sub c1, which is the distance of centroid from the x-axis, as shown, is 60 mm minus h. So yc1 is 60 mm minus h minus 50.93, so 9.07 mm. And the area of the sector is r square theta, or 1/2 r square times this entire angle, which is 90 degrees, or pi over 2. This is area 2, which is equal to this triangle. So that's the centroid, and this is y sub c2. But area 1 is 1/2 radius square times central angle, which is 2 theta, pi over 2 radians. The central angle, 2 theta, 2 times 45 degrees, 90 degrees, or pi over 2 radians. The other way, it is 60 square root of 2 square, r square, times theta, where theta is pi over 4, which is the same here. 60 square root of 2 square, and theta is pi over 2 divided by 2, so pi over 4, so that's the same. Or the general formula is 1/2 r square times central angle, the total angle here, which is pi over 2, and it is equal to 1800 pi mm square. For this triangle, the area is 1/2 the product of perpendicular dimensions. So this is 90 mm minus 60, so 30 mm. So therefore area 2 is 2 times this area of triangle, remember. So 1/2 of 30 times 60, or 1/2 of 60 times 30, that's the area 2. And it is equal to 900 mm square. And its yc2 is Remember, 1/3 of the y coordinate here of this vertex, y coordinate here plus y coordinate of this vertex. So the y coordinate here is 0, here it's 60, and here it's 90. So YC2 is 1/3 of quantity 0 plus 60 plus 90, and it is 50 mm. Now that it is completed, we now apply Varignon's theorem. So the total area is 1800 pi area 1 plus 2 times area 2. So area is 1800 pi plus 2 times 900. So area is 7454.87 mm square. Then by Varignon's theorem, 7454.87 Yg equals 1800 pi times 9.07 plus 2 times quantity 900 times 50. So Yg is equal to 18.95 mm. And remember, Xg is 0. So that's it for this problem. Level 17, determine the X and Y coordinate of the centroid of the shaded area. So if you look at the figure, this is the radius A. So that means the area of the shaded region is area of quarter circle minus area of this triangle here. So let's locate the centroid, individual centroid. Call that X sub C1 and this one Y sub C1. For the triangle, that's the location of the centroid, X sub C2, and this is Y sub C2. So area 1 is pi over 4a square, area of quarter circle 1/4 pi a square, while its area 2 is 1/2 of a over 2 times a, so it is a square over 4. The area therefore is pi over 4a square minus a square over 4, the area of the shaded region. Factor out a square over 4, so it is a square over 4 quantity pi minus 1. Then X sub C1 equals Y sub C1 equals 4r over 3 pi, or 4a over 3 pi in this case. While X sub C2 is 1/3 of a over 2, and it is equal to a over 6. Y sub C2 is 1/3 of a. The height is a, so 1/3 of a. So applying Varignon's theorem, area X sub CG equals area of quarter circle times X sub C of quarter circle minus area of triangle times X sub C of triangle. So a square over 4 times pi minus 1 X sub G equals pi over 4a square times 4a over 3 pi minus a square over 4 times a over 6. Cancel out a square over 4, a square over 4, a square over 4, and simplify. Pi minus 1 quantity xg equals 4/3 a minus a over 6. So simplifying, dividing by pi minus 1, so xg therefore is 7a over 6 times pi minus 1. Similarly, for the y coordinate, a square over 4 times quantity pi minus 1 yg equals area 1 pi over 4 a square times yc1 4a over 3 pi minus area 2 a square over 4 times a over 3. Cancel out a square over 4 again. Cancel out a square over 4. Then we have in the right side, so pi minus 1 yg, and in the right side we have 4/3 a, then minus a over 3. Since 4/3 a minus a over 3 is a, so yg is a over pi minus 1. So again, Area 1 is area of quarter circle, pi over 4a square. Then x sub c1 equals y sub c1 for quarter circle, 4r over 3 pi or 4a over 3 pi. Area 2, area of this triangle is 1/2 of a over 2 times a. So a square over 4. X sub c2 is 1/3 of a over 2, so a over 6. Y sub c2 is 1/3 of height a, so a over 3. This is the area, simplified form, then Warrington's theorem, you'll get these answers. Level 18, locate the centroid of the parabola by integration. So, since the parabola is not shaded, it means that we have to locate the centroid of this parabolic arc. So, it lies on the y-axis by symmetry, barred x is 0. So, let's call that S, and this is the location of centroid. So, x sub g is 0 automatic. The total length of the arc is 2 times S, and xg is 0. The formula for S is integral of ds, and ds is dx square root of dx square plus dy square. So if we multiply dx over dx and insert the denominator dx into the radical, so other expression is integral of square root of 1 plus dy dx quantity square dx. So S is 2 times integral from 0 to 1 of square root of 1 plus dy dx quantity square dx. You can also have square root of 1 plus dx dy quantity square, and this is dy also. The original formula is square root of dx square plus dy square. So it's up to you if you multiply dx over dx and insert the denominator into the radical to have this form, or dy over dy and insert it into the radical to have 1 plus dx dy quantity square times dy instead. But I'll use this because y is a function of x, and it's easy to obtain the derivative of y with respect to x. So y is x squared, therefore y prime or dy dx is 2x. Substitute here. So s is 2 times integral 0 to 1 of square root of 1 plus 2x squared dx. So using the calculator, s is 2.958 feet. Then by Varignon's theorem, so that's ds. So it appears as a point. So x sub c is just x, y sub c is just y also. So this is y, and y is automatic y sub c. Because ds is very, very, very small, and it appears as a point only. So the coordinate of that point is also the x sub c and y sub c, the centroid of that differential element or differential s. So by Varignon's theorem, S total yg equals 2 times integral from 0 to 1 of y sub c ds. So S total 2.958, yg equals 2 times integral 0 to 1 of y square root of 1 plus dy dx, which is 2x quantity square or 4x square dx. Substituting the value of y, which is x square. So 2.958 yg is 2 times integral 0 to 1, y is x square, then square root of 1 plus dy dx, which is 4x, dy dx square, which is 4x square dx. So using the calculator, yg is now 0.4100 of a foot. Level 19, locate the centroid of the plane area shown. Also determine the ratio R1 to R2 so that the centroid of the area is located at x equals negative R2 over 2 and y is 0. So by symmetry, this is the axis of symmetry, which is the x-axis. Therefore, barred y or yg is 0. That's a given. So the area is the area of big semicircle minus area of small semicircle, which is pi over 2 radius square. So area 2 is pi over 2 R2 square, while area 1 is pi over 2 x sub C2 is 4 times R2 over 3 pi, negative because it lies on the left side. Then area 1 is pi over 2 R1 square, and x sub C1 is also negative 4 times R1 over 3 pi. So therefore, area is pi over 2 R2 square minus pi over 2 R1 square. Factor out pi over 2, so pi over 2 quantity R2 square minus R1 square. So by Varignon's theorem, area pi over 2 R2 quantity R2 square minus R1 square xg equals area 1 pi over 2 R2 square times negative 4 R2 over 3 pi minus area 1 pi over 2 R1 square times negative 4 R1 over 3 pi. Cancel out pi over 2 and simplify. So we have quantity R2 square minus R1 square x sub g equals negative 4R2 cube over 3 pi, then negative plus 4R1 cube over 3 pi. So negative, negative, so positive 4R1 cube over 3 pi. So in the right side, we factor out 4 over 3 pi, so that xg is 4 over 3 pi quantity R2 square minus R1 square, then times R1 cube, which is positive here, minus R2 cube. So substituting, simplifying further, xg is 4, 3 pi, R2 is 120, R1 is 72, so substitute here. Then quantity R2, R1 72 cube minus 120 cube. So this is definitely negative. Xg can now be computed. It is equal to negative 62.39 mm. Now for the question, ratio R1 to R2, so that the centroid of the area is located at negative R2 over 2. So negative R2 over 2 equals area equals substituted to this formula here. So quantity R1 cube minus R2 cube. Cross multiply. So we have negative 3 pi over 2 or negative 1.5 pi R2 cube, then plus 1.5 pi R1 cube equals 4 R1 cube minus 4 R2 cube. So for these two terms, factor out R1 square, and we'll have quantity 1.5 pi R2 minus 4 R1, then times R1 square for these two. Then for these two negative terms, put this to the right and factor out R2 cube. So we have 1.5 pi minus 4 quantity R2 cube. Then divide everything by R2. So this becomes 1.5 pi, then minus 4 R1 over R2 times R1 square equals quantity 1.5 pi minus 4 R2 square after we divide R2 everything. So let the ratio R1 over R2 be capital R. So extracting square root, by the way, square root of 1.5 pi minus 4 R1 over R2, then R1 over R2, because this is R1 square over R2 square, then we extracted the square root, so R1 over R2. What is left in the right side is square root of 1.5 pi minus 4. So if we let R1 over R2 as big R, that's the required to simplify the equation. So square root of 1.5 pi minus 4R, then times R equals square root of 1.5 pi minus 4. So this time using your calculator, solve for R. R is 0.5204. Therefore, the ratio R1 to R2, so that the centroid is at negative R2 over 2 comma 0, is 0.5204. So that's it for this problem. Level 20, use the method of composite areas to calculate the centroidal coordinates of the plane region shown. So here is the given figure, and let's divide the area, or let's tabulate the result or the solution. Barred y or yg is 0 by symmetry. It lies on the axis of symmetry, which is the x-axis. So we only need xg. So let's tabulate. We have element, the area in mm square, the x sub c of individual element in mm, and the product area times x sub c in mm cube. So for element 1, let's consider this rectangle here. The dimensions of the rectangle would be 50. Then since this is 40, this is also 40, so 50 by 80. 50 times 80, the area is 4,000. X sub c of this rectangle is simply half of 50. It is 25. Therefore, area times x sub c is 100,000 mm cube. Then for this semicircle, the area is pi over 2 times radius square, pi over 2 times 40 square. So not shown, but let's put it here right away. So pi over 240 square is 800 pi. And x sub c is, this is the centroid formula here, is 4r over 3 pi. 4 times 40 over 3 pi. Then we add 50. So 4 times 40 divided by quantity 3 pi plus 50 is, put the value here, 66.977. Then the product, 800 pi times 66.977 is 168,331.56 mm cube. Then for the circle, which is treated negative because we are going to remove this, is pi 15 square, and it is equal to negative 225 pi. X sub c is, as indicated in the figure, 30. So the product, negative 6750 pi. Obtaining the sum of areas, 5806.42 mm square. Obtaining the sum of these columns, because x area, xg is summation of area x. So this is summation of area x. Sum is 247,125.81 mm cube. Therefore, xg is 247,125.81 divided by 5806.42. So xg is equal to 42.56. This sum of area x is also called QY, because this is the sum of the moments of areas about the y-axis. So that's it for this problem.